Hello, YouTube. Hello, Ben.
Hello.
How are you?
I'm well. How are you, my friends? Good to see you again.
So we got people saying hi in the chat window. Hello, Mondo. Hi, Kevin. Yes, it's showtime, somebody said.
Yep, we're on, and I've confirmed it. I'm probably echoing because I'm not on my earbuds. Can anyone
you're
tell
fine.
me?
You sound fine to me. Go ahead, say something.
Hi. I'm actually asking on the chat in YouTube.
Yeah, go ahead.
I'm hands-free, and I want to make sure I'll need to get headphones if we have an echo issue like we used to back in the old days.
We troubleshot. You know, I still crash my sound driver. That's what happened 3 weeks ago when suddenly we couldn't hear one of the channels, and then there was echo, and I had to change the settings. My sound driver had crashed, and it's a sound driver that runs my USB-based mixer panel. And so it's the crash I get that causes echo is not something a normal person would have to go through. But here we are.
Yeah.
Cut the Bodge Wire. They're already shouting for the Bodge Wire.
Everyone's very antsy to see that.
Well, I can only do it once for the first time.
Yeah, it'll be a very short show if we just jump straight to that, right?
Right. We have to kill the first 15 minutes here first, talk about our Discord channel.
Yes, if you're not on our Discord already, go to the Coriolis Effect, Coriolis-effect.com. Discord link is at the top to join our Discord channel. Speaking of Discord, I wasn't on there. I haven't been on there much. I do apologize to pardon me, my soda's coming up. I do apologize to everyone that I haven't been very active there. I will try to get more active. What I did want to say was we actually had some super intriguing stuff appear this week in the projects channel and the science channel. Wes actually posted some cool videos. Looks like you got Wes. I don't know if Wes is on right now. Probably. Hope so. If you are, hi Wes. Thanks for posting those super interesting videos about measuring X-ray emissions from an oscilloscope, an older oscilloscope. So Bill used to be a repair guy way back, like the very beginning of your career. You by repairing it, which is, in my mind, actually probably the best way to learn anything. The best mechanics or mechanical engineers learn mechanical principles by working in car engines and stuff, right? So
it's like learning wax on, wax off before everything else. Yeah.
Yeah. So I was thinking, why X-rays from a CRT, a cathode ray tube?
Right. Well, that's how you make X-rays, right? An X-ray tube is a high voltage and a target, and you pound it with electrons, and you get a scatter from it. And in the old days of TV sets, we had to check as TV repairmen. One of the checks we would do is we would check the high voltage on the tube to make sure it was within the X-ray limits, and there'd be something printed right inside the housing. And for example, an RCA had a maximum kV of 25 kilovolts. Zenith was closer to 27. But if the RCA got up to near 30 kilovolts, it'd be an X-ray source, more than you wanted. But as you were saying before the show, these are probably, we grew up living with X-ray sources in our living rooms. So
I don't like that.
Who knows that we may not like.
Right, yeah, or none of us ever knew. None of us ever even knew that we were staring at an X-ray box growing up.
If you weren't a TV repairman, you certainly didn't. Yeah, correct. So I see you're going for the headphones.
Yeah, Kevin was saying my audio is a bit low. So, but Skype doesn't automatically update the source, so let me just change it.
So while you're doing that, another topic that was on Discord was the grounding of your oscilloscope. And this is,
Oh, yeah.
there's no good answer here, right? Because if you use the ground pin on your scope, that grounds, when I say the ground pin, I mean I should have had one, here we go. This pin, right here, this guy. If this pin is in on your scope power cord, you're grounding that clip that you use to measure signals will be grounded to your electrical box in your basement, wherever it is. And that means when you go to ground that, clip that ground onto something, you're shorting it to earth ground. And that's fine if it already wants to be earth ground. But if it wants to be a floating ground, and I'm sad to say I have had it happen once. It happened when I slipped. I didn't intentionally go to ground on a floating ground, but I slipped with my ground probe and popped the fuse. I had to fix a fuse and I got it right back up and running. So that you need to be cognizant of that. So I always use these little ground adapters. Back in my Commodore days where I was an animal, I was known for just ripping this prong right out. I would just tear it right out with a pair of pliers. And I still do that to some extent these days, but I have a handful of these little guys. Now, once you use this on your scope, you're probably violating OSHA regulations that says, hey, you don't want to get between a badly grounded appliance and real ground and be the conductor yourself. So that's why I say there's no good answer. If my lawyer were here, he'd tell me, Bill, tell them to ground their scopes. But the engineer in me says, well, you got to unground them sometimes. Now, the opposite's true for your soldering iron. I've seen a soldering iron with a floating ground just bugger. It buggered like 4 FPGAs in a row. Somebody else was doing it. And I kept trying to tell them they got to stop using a Radio Shack soldering iron and get a real one. And real ones are made to ground. They're made to not be a source of ESD, let alone that floating 60 volts AC float you get sometimes.
Oh my gosh,
when there's no ground.
Yeah. Yeah, so, grounding's super critical.
Yep.
Yeah, I'm just looking for different things. But why is this important? Well, it's super easy to forget, right? What you want to do, especially if you're working on DC to DC converters, it's desirable to measure the voltage between two specific points in the circuit. And the lower point is not ground. You could be measuring the voltage across a winding, which the upper point maybe is at VCC and the lower point is getting pulled down by an open drain switching device, MOSFET.
Right.
And how do you do that? Or you might want to measure the current through a current sense resistor, and the current sense resistor may not be tied to ground at one end. It may be tied to, well, here's the thing. This is also why when you're designing and working on and troubleshooting power supplies, this is not negotiable. You must have two very important pieces of equipment. One is an isolation
transformer. Yep.
Right, with at least a 3,000 volt isolation dielectric strength, or tested barrier to 3,000 volts. Should be double insulated, because you're taking power out of the wall, offline mains. You isolating it with a transformer, and then on your primary side of your DC switching power supply, you have these high voltages still, so you still have to be careful, but at least you can actually put your oscilloscope ground probe, as long as you're not touching the ground anywhere else in the power supply. You can actually measure between 2 points, but you can't do multiple channels, right? Because both channels share the same ground on the oscilloscope. So if you measure a voltage across, and this, I've seen people blow up scopes and the power supply they're working on. This actually happens frequently if people aren't used to doing power supply debugging. You'll hook up your ground clip and your tip clip across a wind-in of a transformer on the primary. You've got your safety isolation transformer, so you're allowed to do that, and you're measuring that, but you get one channel, and then it's like, well, I want to measure this other channel to see, you know, if there's dead time issues or something. And so you go to hook up, you know, you turn it all off, you go to hook up the second channel and then power it on, and smoke comes out because you've forgotten both the ground clips on the probes are connected together.
Are the same ground, right.
And,
so Alan has said, go ahead.
Well, no, I was just going to say the actual ground of the oscilloscope is also connected to the chassis, or should be, and every scope I've used has had a dedicated ground binding post or something that you can hook onto. Yeah.
So now Alan has said never float the scope. And again, I would not argue with that while talking to a bunch of people for safety reasons.
Float the device under test, not the scope.
Right. So my experience though is, like, for example, a Commodore system like behind me, the disk drive, you know, needs to be floated, and then the CRT needs to be floated. So you end up finding all the different grounds, and what happens is you can actually, now you do have a hot chassis, because the X capacitors in the EMI filter form a voltage divider and will actually take your ground up to 60 volts. So you need, somebody has to be grounded. Alan's saying ground the scope, not the DUT.
Well,
I won't argue with that.
He made another really good point there too. If you want to measure between 2 points, it's better, correct practice to measure the 2 points with 2 channels and use the differential function.
Yeah.
Because scopes, actually, even cheap scopes with 2 channels have a difference mode.
Right.
This is also why you want, for power supplies, you really do want a 4-channel scope if you can get one. And ideally, if you can get true differential probes, you can even, if you've got the money, get isolated differential probes.
Right.
They cost a lot, but if you got that, you could have 4 full channels of differential measurement. But yeah.
Yeah, my main point would be to be cognizant of the ground, that ground pin is the ground lead on your scope. That's the main thing I'm trying. Now, you had an interesting answer. You have a battery powered scope, right?
Yeah, I got, and these are now super available. They're not by any means high end, not you know, you wouldn't use it for anything where you need something calibrated, but if you're just troubleshooting a design and need some visual feedback to cue you that things are correct or not correct, let me see if I can find a link to the one I got. I haven't really run it through its paces yet, so I can't vouch for whether it's super accurate or high quality, but it's what I needed. I'm just bringing up the AliExpress page that I found it on. Let me see if I can bring it up.
So Mike Fikes said, while you're doing that, he said he had an accidental floating ground in his house. And one thing that's prevalent laying around my house are those 3-prong AC testers. And I'm religious with those things. I'm always shoving one of those in a socket and looking to make sure that when I first moved in the house, I found one of the outlets, somebody had hooked a switch between the neutral and ground instead of between the hot. And so it literally left the whole outlet live, you know, so I found that with my tester.
Ouch. That's why you go to Home Depot or whatever your hardware.
That's where I get them, yeah.
Sorry. Still multiple trains of thought going here. Yeah, go to the hardware store. You get those things with 3 neon lights of different colors, and you plug them into the outlet.
2 yellows and a red.
If you got some, and if it's wired correctly and everything's good, you'll get 2 yellows or 2 greens or whatever it is. Yeah. Right.
So, all right. So, you ready to talk about what we're going to do here today?
Yeah, well, I am if you are. I'm still busy trying to
You're putting a link for the scope. Yep.
Yeah. It's the brand name in it was Finrissi, but there's a lot. There's a lot of them that are the exact same scope. It looks like it's made in the same factory, but different brands.
Right.
Gosh, it's not a 1014. It's not a 1013, but it's like a 1013. Mine's, I think, a 1016. Maybe it's a 1013. I'll just throw a link in here. It's called Tablet Oscilloscope. I'm going to throw the link in the YouTube chat.
Okay.
Maybe it won't let me because it's an AliExpress link. Yeah, YouTube doesn't like it. It's too long.
Wow.
Never mind.
We'll put it in Discord.
Yeah.
So, all right. So today, one of the things we were going to talk about is, let me expand the board here real quick. Well, first, let me tell the story. Whoops. And Ben, you just beeped, but you're back.
I know. I dropped and came back.
So, years ago, 38 years ago, I was working on a project called the Commodore 128 for a little company called Commodore. And we had done our final rev of the PC board. And we had done it under duress. We had to finish it during 3 days of 24-hour days. So we ran all 3 shifts. And I just basically took my air mattress and my Army sleeping bag, and I slept in the CAD room, which was nice and cold and chilly. And it was so cold, in fact, that I had taken my, it was the Burger King version of Egg McMuffins. I took that into the room on Friday and ate them on Sunday. They were still good. So it was just that kind of environment. So
well,
when we're all done,
food never goes bad, Bill. You know that,
right? Yeah, but it was still nice and refrigerated. And during that time, we finished this board. I'm using Johan Grip's version since I can wave it around real easy. This thing is horrible, right? By today's standards.
Johan's is amazing, but that's not what you meant.
But the board layout, right? I don't mean Johan's work is horrible. I mean the board he had to work with is horrible. The actual board you see here on the bench it's a 2-layer board. It does not have a ground plane. It does not have constant impedance of anything. The DRAM section is well laid out.
In 1986, who had more than 2 layers? Any board?
The business, not in consumer, we didn't. The consumer version of this board would have cost me like $100 each, and my total cost was supposed to be $50 for the whole board or for the whole assembly.
You just didn't do 4, 6, 8 layers. You had 2 layers. Otherwise, the product was too expensive.
The Z8000 people had 4 layers to play with, but they never went to production, so they never had to deal with it. So, and what we did last week was we stuck it on a TDR, a time domain reflectometer, and verified that was about 95 to 100 ohms on this one trace. What happened was, so if I back up a little bit, we get these boards back, they seem to work, and what we used to do is every 3 weeks I was revving this board because we did the Commodore 128 in only 5 months' time, and I never got more than 3 weeks away from a working board. So we finished the CES show January 6th, still remember the date I forget the year and I remember the date, I think it was 1986. And then we do the final rev of the board. We've already submitted for FCC, which means we can't move any parts, we can't add any parts other than passive components, resistors, transistors I could add, that's why there's so many transistors on the board. And we get the board back. We're ready for mass production, and 20% of the boards don't run on the Z80 mode, on CPM mode. And the whole story is, my boss and I weren't getting along that week. And I said, oh, wow, there's a problem, and he's pissed, and I'm like concerned. And he takes me off the project. He figures it's time now to swap out the engineer, do the last 5% with the new engineer. I'm like, fine. I'll just go home and take a shower, which I did. I took the week off right in the middle of January. I'm off for a week, right? I mean, I'm going to the office. I'm catching up. I really am. I'm catching up on everything. But he comes into my office on Friday and says, fix it or you're fired, which is the second time he has told me this. And I didn't take it badly. I'm like, cool, I'm rested, I'm relaxed. This poor guy he had put in charge of the 128 for a week, it wasn't fair to him. He didn't know this board like I did. And the way so we had some kind of layout problem. We knew that. The way we got around not having impedance matching is we were very slow in the old days. If we look at this, and I'm going to expand the scope image here in a second, but we had tens of nanoseconds to wait for things to settle out. And that's quite simply what we did. We lived with reflections on a lot of lines. We didn't like reflections on clock lines. And a reflection is where a signal gets to the termination and the impedance is mismatched. If the the load isn't always 50 ohms. We measured as 50, but Mike Fike stuck an LS part on his VNA and he got like a couple K of impedance. Well, how do you match a couple K?
Because it's what the input. Think about the input of a logic gate in an IC, especially NMOS back in the day.
Right.
You have a pin which has some capacitance and inductance in the package. It goes inside, it gets wire bonded to the die, and on the die, the first thing it sees is probably some PN junctions for protection. So some diodes that clamp the voltage on the input
JFETs,
to VCC and ground. So the voltage can't go more than 0.6 volts above or below ground. And then beyond that, it's a MOSFET gate.
Right. And in the direction of your DRAM, there was huge capacitances. DRAMs were big honking capacitors, the RAS line and stuff.
So it's like you're driving a little capacitor with some series inductance. So A, you have a resonant frequency, and B, it's not some 50 ohm ideal load. And we wanted gates, they were deliberately designed to be very high impedance. That's what we want, because you may want to hang many, many, many gate inputs off one driving source.
Right. It's like, and I equated this problem to blowing into a flute. When the 6502 drove the trace, it drove it from the end, but the Z80 drove it from near the middle. Now, that turns out to not be as critical as I thought it was, and Alan just mentioned discontinuities along the trace as well. When we put it on the TDR, what we found was the trace was about 95 to 100 ohms. Jungle, I call this jungle tracing, right? Where there's no ground, you're just crossing other traces and just going. That's why I say this thing's horrible. Again, not Johan's work, but the board. But I only found it vary by about 10%, and I thought, aha, 10%, that's enough to create ringing and whatnot. But I'm not sure that's the issue, and that's why we're going to cut this wire today to see what happens to the waveform. Now, the wire, let's talk about the wire. So my answer, my boss tells me, fix it or I'm fired. And I'm like, fine, I will. I'll go take a look. And I got lucky, all right? Now, part of the luck is I knew where to look, because it had to be something particular to the Z80 alone, because the 6502 mode really was doing well. So I looked at the traces when it was booting Z80 mode, and I saw a little wisp of something. Now I'm doing this on an old analog scope where if you turned up the brightness, it just blew you right out. You couldn't see the trace. What I did was a trick. I did two things. I moved the bright part of the trace off the scope so that it would actually kind of glow as it hits the inside of the scope, secondary emission or whatnot. But the other thing I did was I stared in the scope, and then I would look away at the wall and I would see a reverse image. I would retina burn, and I would see black on white when I looked at the white wall, and I could see something going on. Now, I showed this to Frank Palea, and Frank's yelling. He's the guy that did the Z80 stuff. He's going, I see it too, and he's pointing at the wall. Meanwhile, I showed it to a friend of mine, Headley Davis, and he's looking at me like I'm freaking nuts. He's like, what are you staring at the wall? I had him do it, and he didn't see it. So
you are a little bit. It takes a degree of insanity.
It takes a little bit of
to become a electronics hardware designer in the first place.
Yeah, well, I would jokingly tell you half of us were alcoholics, but it may not be quite as big a joke. It was quite a time and quite a time to be in the business, and the people. And I mentioned that because we always wondered, did working at Commodore turn you into an alcoholic, or did you do well at Commodore if you were an alcoholic? So it was we didn't know what came first, right? So, but we were wild animals, and so here we are. We're looking at this trace, and I throw it on my digital scope. All these years later, I have booted one into. Oh, so the answer was, and then I'll talk about the trace on the scope. So my answer was this red wire. I'm going to point to it here.
Yep, the Bodge Wire. That's the famous Bodge Wire.
Right, and that's on all 5-6 million C128s, and because it worked. It lowered, what we found with the TDR was it lowered the impedance by about 20 ohms. Put it on there, and if you model it as two transmission lines in parallel, it makes sense. If you think about it not reflecting off the end because it's now a loop, it sort of makes sense. So what I knew was it worked. And I had some kind of confidence. I don't even remember why I was so confident, but it's like I put that wire on there, fixed the first unit. I turned to the guy in the lab, said, fix the others the same way. They all worked. And over the weekend, we ran 10,000 units. Unfortunately, all the people from the R&D lab except me had to go down because I had a horse in the race, right? So I'm walking around with a case of beer in production, handing them out to all my friends who have to spend their weekend now doing a mini production run at 10,000, which would be a production run anywhere else. But for us, it's like, prove that herd is full of shit. That's what that run was all about. And they had to admit it worked. 100% adding this wire to this board made the Z80 start booting again. So what I'm going to do today is cut that wire and see what it looks like on the scope. Now, I've got it on the scope. My digital scope has a mode where I can catch this. See this red trace? The top trace is the bad address line, A3. So it happens to be an address line that was bad. And below it is A2. And we see that it's going in the opposite polarity, and it's happening a little earlier, right?
Yes, so
and so what
A2 has a better edge rate.
Has a better edge rate. Right. And they both have this weird little floaty bit right here. And the Z80 is notorious for doing this. You can see the internal bus of the Z80 think, is the way I describe it. In the 6502, it usually either puts out a low or a high, or it's it's going into high impedance or coming out of high impedance. But the Z80 actually outputs some illegal voltages between clock pulses, so I'm not surprised to see that. But what's kind of a surprise is this slope on just this one address line. If you look at all the others, you don't really see this. So my point is, I don't think the trace on the board is really bodged. Really bodged like I thought it was. I thought we had accidentally built a microwave trap or something. Hang on, I'm trying to pull this down so I can talk. I thought we had created some kind of RF trap or notch filter or something. And now I'm starting to think it's just a data sensitivity, that this was the data line, the address line that happened to hang out there, and I lowering the impedance happened to fix it. So that's the theory. Any counter theories? Anybody want to float out there before I cut this wire?
Or are there comments on it?
So we'll give it a second. So here's the part right here that we're looking at. And so what I've done is I've set my cursors. The bottom trace here is RAS. Let me pull this back up now. So this bottom trace right here is RAS. It is a godlike trace, a godlike signal. It needs to have the address lines be absolutely stable just prior to it falling. And you dare not wiggle the address lines the least little bit during the RAS cycle, or you will create collisions inside your dynamic RAM, and multiple cells will come online and you'll get a corruption, not just of the location you're writing to, but all over the DRAM. So it's a hairy issue to have stability in this window. So right here, I've set it right around when it starts to cross the upper threshold and goes into unknown.
This is
VIL or VIH or VOH, depending on where it's an input or output. But call it about 2.4 to 2.8 volts. And here is the last trace, A3, right as it goes above the high threshold. And the time between these, let's see if I can get the cursor command to come up. And I'm measuring about 29 nanoseconds, which sounds like forever, and it really is forever. So the question is, if I've got about 30 nanoseconds between here and here, why did putting a second wire on the board matter? So if there's no questions, I'm going to go ahead and cut this. What's this? I forget. Is that red trace a severe instance?
Mike, hold on. Mike was
Yes.
asking the red trace, the faint red trace that we're looking at that has that lag. Mike was saying, is that a severe instance of metastability?
Metastability, right. And I don't believe so. I think it's late address line coming out of the processor. There may be metastability inside the processor.
It certainly would cause metastability with the sampling being the issue, but originally, like if without the Bodge wire, is it metastable? I'm not sure. I think it's a delay problem, but we're about to find out, right? And
or we'll find out nothing. And
just a comment from Board. He's saying thank you for us doing this. He really wanted to see this and was requesting it. And Autumn.
Oh, cool.
Autumn.
Cool.
Nice work. Just did a 35-year restoration on your C128. I hope you do a video or have some videos to share with us of that. That would be awesome to see.
Yeah. Given it took us 5 months to make it, and it was designed to last a year. And here they're working 37, 38 years later, which just blows my mind. In fact, that's why I haven't cut this wire before now, is I had to get a working floppy drive. I had to get a working floppy disk, again, 38 years old, and boot in a Z80 mode with an old Commodore monitor. So I've got it all hooked up and ready to go. And I then turned it off carefully all week because I didn't expect it to last all week without breaking, right? So here we are.
These things are... But think about it. Voyager, built in the 50s and 60s, is still out there sending stuff back to us.
That's right.
So you know what? Never underestimate how awesome things are. Once you bring... It's like metal fatigue, you know? You've learned a little bit of material science. You always, if you get into PCB design, you can't help but end up learning a bit of material science.
Right.
You know that metals fatigue. We all know this, right?
They also walk around on you. They migrate.
Most metals, not all, most metals have a deformation threshold below which you can keep deforming them indefinitely as long as you don't cross
modulus of elasticity.
That's it.
Yeah.
And as long as you don't cross that, they will last indefinitely without cracking. Right. And that's why we're able to have springs. And so, but the same things apply in every material, and in electronics, the same kinds of principles apply. And it's, if you look at the dimensions of 80s era NMOS and the physics of how it works, it's no surprise it should just go on and on and on, provided we don't cross those boundaries, right?
Right. Now, we did throw a curve out there. We were, in addition to NMOS, we were rolling out HMOS1 and HMOS2, and those were new processes for us. And so for the TED chip on the old Plus 4 series, it's got lower reliability. It had lower reliability when we made it, and I'm not surprised it's got lower reliability in a long run curve. It's like baking a cake. It's not all math. Some of it is recipe and art. And making chips in the old days was art. So Johan said that his experience is the 128 is more reliable than a lot of Commodore computers. I agree with that, actually, and it's because we made sure we got the DRAM timings correct as a first step, because the Commodore 64 DRAM timings aren't correct. They just aren't.
And how mature?
The Amiga, I expect to work correctly.
How mature were the DRAM chips you used in the 128? Because that's a big deal. That's a big factor there. There's a lot of, like, if you're using DDR4 memory, for example, but if you had DDR4 back when it was just fresh on the market and expensive, chances are those modules are now failing or starting to get errors, because the first generation
we had pretty
of any
good
RAM
DRAMs
is dodgy. Yeah.
By that time, but however, there is a brand, Micron, does have some failure modes we still see today, and I say that because it's not unusual to have to replace all 8 or all 16 Micron DRAMs in a board. They just they as they sit, you know, room temperature is still temperature. They're going bad, you know, even as they're sitting. Entropy is winning, right?
And you're dealing with really tiny insulators as the storage cells that you can start with a tiny pinprick of static, just a few hundred volts, and it will still work. But years later, you get electromigration through that pinprick.
Right.
And eventually it shorts out and you've got a stuck bit. So
yeah, you know, that's a show we could do. I did a thing for VCF on component aging, and it talks about all the ways, heat and cold and humidity and all the things that can cause the migrations and stuff. So, all right. So, yeah, Johan just agreed with the Micron DRAMs being the biggest failures. So, all right, that's enough talking. I'm going to go over here and clip a wire as close as I can. Now, we're watching these little red traces. Matter of fact, I'm going to show you the different modes of the scope here. Let's see if I can do it real quick. We did not have these modes available to us in the old days, obviously. So that's why I had to use just a real bright scope setting. But right now, I've got it on spectral, I think. But I'm going to show you some modes where I can actually pull that least bright signal out of the noise. So hang on a second.
Yep. It's like
I'm going to have to get my glasses. Hang on.
Okay. Now it's currently, it's in spectral mode, but you're going to intensity mode, right? But the modes on TechScopes have a specific name.
Yeah, and I'm having trouble finding the cursor, and it's because I get in this mode when I'm talking. Hang on a second. Acquire, menu. Fast acquire. See, so now I'm in spectral mode. So if I go to
it's temperature mode versus spectral, right? Or inverted.
Yes, right now
inverted
it's in spectral.
Can help with faint signals too.
So here's temperature mode, and you see that the blue, it's now blue, and it's harder to see than spectral. So we'll try spectral again. That's pretty cool. Here's normal, where we can barely see it, but this is better than I could see on my old analog scope. And then I'm going to invert it where it actually it's like it sounds. And there we see the trace bright and clear.
Yeah.
So very cool stuff we can do these days.
That inverted mode is a game changer.
Yep. Now I'm going to use the little red mode because that to me is how my eyeball's calibrated. So let me do menu off, get these out of the way. All right, I had the recorder run because I can only do this once. So here we go.
Oh, wait. Before you do this, is there a way we can overlay your camera over the board next to the trace on the scope?
All right, hold on. So you mean like that?
Yeah, so we can actually
watch it.
Yeah, so we're watching that dim red trace there.
All right, and my sharp cutters aren't cutting so sharply on this 35-year-old wire. Let me find better ones. I had pretty sharp ones pulled out. Well, I'm trying not to bump the traces.
Now I see a lot more noise leading up to the rising edge, but the rising edge still appears to be at the same time.
Same place, yes.
But is it that noise, that metastability in the middle?
Yeah, so let me change the spectral mode here again if I can.
And something else that just occurred to me too, that you still have that wire, and from the pin on the Z80, you have
They're still hanging, right, I've only cut one end of the wire.
You have this really giant stub, so you just created a massive antenna, but it could be absorbing enough energy. Yeah, so cut the other end and we'll see what happens.
Right. And this is kind of what I thought it would be. Now, look what's happened at the bottom.
Yeah, we've got even more metastability or unsettled state.
Something's going on here. Right. And if this gets high enough that this is what I remember seeing, was I saw glitches from the bottom coming up. I did not see the upper change, but what I saw were these glitches here. Boy, I wish I could flip a switch and have it go on and off, because I'd want to see how much this has risen. And I'm talking about right here. I just realized I wasn't pointing to it on the right screen. So now we've got this hump that's probably crossing the VIL threshold. So it's not this thing here. This is probably the red herring. This here is probably the issue, which is holding ground below VIL. And see how it's coming out all the way out here. Let me switch the mode on the scope, see if I can do that again. So require...
and you have the 128 monitor all hooked up at the moment, or no?
I do. I have it in C128D mode. I mean, in 80 column mode. But it's still running. When the Z80 crashes, these traces go away. That much I do know.
Yeah, look at that. So move the menu. That
looks like a smoking gun to me right there. This is garbage up too close to RAS.
Yeah, yeah.
So, wow. Now I wish I had an analog scope, but I gave my good one to Terry Ryan, my 465 400 megahertz one. So I can't recreate this. But that to me is kind of what I was looking for. I didn't expect the top to ring, but I wouldn't have been surprised if it did.
We have a lot more ringing on the bottom preceding this as well than we had before.
Yeah. So let's change modes here again. Let's go to regular mode and just take a look at, see what we see. And again, these are happening infrequently. And there it is. This is what I saw ever so long ago. See this lump forming right here? I caught, remember, this only happens on 20% of them. So what was happening was during this time, we were getting noise spikes, which may be due to crosstalk, right? Or it could be ringing, or, you know, it's a data sensitivity of some sort going on. So I don't know so it rings all the way out to here. Okay. So a picture trying to find that. You know, and then convince your boss.
Storage scope. Yeah.
Right. Yeah. And then the only storage scope we had was a 466, and it was like Alan can correct me, a 50 or 100 megahertz something.
Alan just made a valid comment too, that we now have a much thicker Logic 1 than we had previously. Looking at the current normal mode trace.
Right.
Yeah.
Right. Let me go back to inverted here just to, because I can see it, but I don't know how well it's coming across on through YouTube by the time the reduction, the compression algorithms run. And menu off. My favorite button, menu off.
Now that remote screen from the scope, that's through a web browser or through an application?
That's through a web browser. Yeah.
Oh, that's neat. That's neat.
So yeah, that's just regular old HTML doing that.
So
All right.
flipping modes on that machine between Commodore mode and CPM mode. It's currently, you said it's currently in 80 column mode. That means CPM or that means CPM?
So it means that. Here, I'll show you what it means. There's no room on the bench for the keyboard to be plugged in with its keyboard adapter. Yeah. And on here is the 4080 column switch.
Yeah.
So to unplug this, it says, "Oh, you're in 40 column mode," because I don't see the 80 column key closed. So I'm the way I know I booted in the Z80 is it does put up a telltale. It says booting CPM on 40 column display. Mm-hmm. And right now I'm just using a DB25 for 80 column mode.
Yep. So you basically jump where the switch previously was.
So yeah, this is entries. This is garbage here. Look at this noise in here. This is and in 6502 mode here. Matter of fact, let me show you 6502 mode.
Yeah, that's just completely gone.
Yeah, we get all now. There's still, so this will start when I'm starting to think it's some crosstalk in here, right? The 6502 got done thinking way out here, but look at this bump that's here and here. There's probably something going on the board that coincides with that in the time domain.
Yeah.
But and I'll go ahead and boot back into Z80. You can watch it go into Z80 mode.
Yep.
So he's doing some thinking, and then he should whoop, and there's the culprit.
There's the delayed, and a lot more noise and ringing after that too. So,
right, and that's what the 25-year-old Bill Hurd keyed off of ever so long ago. Is I saw that jump in there, and I go, aha, Z80, that's what I'm looking for. Yeah, Alan mentioned 466 is a 100 megahertz scope. Yeah. So it could be ground bounce or crosstalk. I can look into it further. And Johan's going to see if he can replicate it now on his. But I imagine there's if I look at the young Bill Hurd would have known, if I knew the absolute time from phi, the clock, when this lump is, I might even know what that is going on on the board right where this lump is here.
Yep. Yeah.
So, but you can see the 6502 never output an illegal voltage, but I'll tell you that this voltage right here coming out of the Z80 is
totally
illegal. Bad. And it could oscillate through the LS257s, the multiplexers for the DRAM. And in fact, the CPM cartridge that did not work on the C64 very reliably, they thought it was the speed of the LS257s, and it wasn't. It was their lower threshold voltage. One brand would oscillate when the Z80 spit out an illegal voltage, and one brand wouldn't. And everybody thought it was speed, and I never looked at it till we troubleshot the 128, and we realized that we couldn't stop the clock right there. Frank Pallea added some circuitry that said, if you're on that illegal thing, go one more clock. Just keep going, get past this. Do not sit there with 1.14 volts on the address line during a DRAM cycle, or bad things will happen.
That, by the way, Bill, is a Doctor Who meme. Stop the clock. Anyway, you just mentioned something too, which we did talk about at length in a previous episode. So if anyone's on the stream right now and you haven't been with us before or for very long, I want to say about 6 months ago, we did have one episode where the whole episode was pretty much just about metastability. And because Mike Fikes, hi Mike, knows a lot about this stuff too, and he sort of triggered us somehow into talking about that.
You're breaking up. All right, we lost you there. You're back. So last we heard was Mike Fikes' metastability.
Fuzzy. Yeah,
There you are.
so I was just saying, we go back and look at the old episodes because we had a whole episode dedicated to metastability, and it actually turned out to be a really good one. And how you can, if you have one badly designed section of a circuit that becomes metastable, you can wind up with oscillations propagating throughout your entire product and bringing the whole thing down.
And I talked with a guy that did an ECL design, the old emitter coupled logic, which had like a 50 amp negative supply, and he said when they single stepped it, it was fine, and when they ran it at speed, it popped the 50 amp fuse, and they traced it to a single metastable gate that propagated through the whole thing.
Yeah, it's crazy. What like, you really must avoid it.
Right. Well, I'm trying to think what else to show since we've got this all probed out here and whatnot.
Are you going to repair it again, or leave the Bodge wire disconnected for a little while and let it run and see if you can get it to crash?
Well, now that you've said that, I can do that.
Yeah, I think it's worth it. Like, just let it run for a few days and see if and when it crashes and what might happen. Boy, that looks even clearer when you zoom out a little too.
Yeah. So let me show the difference between Z80 mode and 6502 again.
It's Z80, now 6502. There's a lot more ringing on that low end, but there's much less or much more timing margin.
And it may not even be ringing. It may be the internal. See, right now the 6502 is coming out of tri-state, and because it shares the address bus with the VIC chip. So the two chips are jumping on and off, and if you look at the frequency it's here, it's actually 2 meg because there's 2 RAM cycles for every clock cycle of the 6502. I'm just superimposing the two of them. But during this time right here, the 6502 is coming out of high impedance, and I've seen it does late thinking, right? It's like gates are still shuttling around and stuff before they settle down. So yeah, Alan's wondering if it would crash more often with the probes disconnected and whatnot. When I originally found the problem, it wasn't on the hairy edge. It either broke or it didn't. I was lucky in that, and when I added the wire, it very cleanly fixed it. You know what? I have a wire around here somewhere.
This is the other reason probes have a 10x mode, right? It's not just to measure a higher voltage. It's to make the probe higher impedance, so it's less interfering with the thing you're measuring.
So I'm going to try and put a wire back on.
Okay, it's still in C64 mode, by the way.
Oh, thank you.
You could do it with C64 and then switch mode and do it again.
Yeah.
So we're in 64 mode. Now we're back in Z80 mode, CPM mode.
Yep.
And you're going to reattach that black.
Yeah, I've got a second piece here I'm going to use.
Okay. This is where I get real nervous that I'm going to short something out. Look at that. That ringing definitely is.
Changes, doesn't it?
It's definitely reduced by adding a wire.
Right.
That's pretty clear.
So reducing the impedance of it. So Alan mentions 10x is also is used to lower probe capacitance. Not sure if I thought of it that way before.
Yeah, that's right. So to get more bandwidth. Yep.
That's cool. Yeah, Alan, I would have sworn that the probes on my MDO, my TPP 1000s, I would have sworn they had a 50 ohm mode, termination mode, but I cannot find it. So I don't believe it does. Let me know if I'm wrong, but so to terminate in 50 ohms, I actually went back to a BNC connector the other day. So, all right. Well, we got 5 minutes left here. Any comments? Any questions anybody might have, or don't do this again, or keep tearing away at it?
Other topics you'd like us to
how about we break the Z80 clock? So that was a discussion from Discord. Somebody talked about the other way to do a Z80 clock, which is with open collector devices. And, because I used a funny transistor to pull up past, I tried to pull past 5 volts, and in doing so, I got rid of the RC. Well, if you use open collector devices, and you have to use like 3 in a row, and like a 220 ohm pull-up, right, 20 milliamp pull-up, if it's resistance, but it gives you 20 milliamps of current. That to the young Bill Hurd was kind of a non-starter, and we can talk about why, but I wouldn't mind going into the Z80 and showing what it looked like before I added that little boost circuit. That might be something we could. When I'm done, this C128 won't work at all. Is my point.
Well, just whatever you do, make sure you can restore it back to working condition.
Well, yeah. That's why I clipped both ends of that ground wire, or that Bodge wire, is just so that it's probably in its best operating condition.
Oh, Hey, this is really cool too. On the Discord, Maradel, which is my friend Mark. Hi, Mark. Mark's also got an awesome channel on YouTube called The Water Mill. So look for restoring a water mill in Scotland. You'll find Mark. He's also a brilliant electrical engineer and video producer. But Mark posted screenshots from our stream just now with before, after, and difference. He actually put it in, I guess he used Photoshop or something to take the difference between the screenshots to show a color map of the difference. So it's there in the Discord general channel if you want to see that. Thanks, Mark. That's awesome.
Yeah, and I had thought, I'll bet my scope is capable of memorizing one of the traces, creating a mask out of it, and then showing the difference. But I didn't want to sit here and try and do that and screw up right in front of everybody. So it's again, I'll throw that one to Alan and say, is there a way I can memorize that trace and show a difference of the two from memory, subtracting out real time? So, matter of fact. Speaking of, let me see if I can put it up here. I just love this scope, but one of the things I did was I looked at the scope's math capabilities. I don't know if you'll be able to see it, but here's the math I can do on a scope probe.
That's sick. Basically everything.
Yeah, so you can measure a negative overshoot, undershoot, all that happy stuff, and actually set up math to do it. Now, I haven't done it yet, but I just love seeing this kind of capability.
That plus combine all the regular expressions, basically. All the normal logical tests for true, false, and normal math functions in addition. I'm sure you can... It's probably, it's got all the trigonometry in there. That's cool.
Right. So somebody asked about about the C128 DCR, and I don't know anything about the DCR. They did that years after I left, and it's. I'll say that I've looked at the DCR. I don't like the noise I see on the screen. I don't like the way it's grounded, just from having observed it at a VCF. So the DCR came later, and I'm glad it worked for him, but I don't know. I think Commodore Germany might have done it. I haven't found. I keep asking who did it. Nobody will fess up. Oh wow! So Alan's saying I can assign a variable to knobs A and B and tweak them live. So I can influence the math with a variable knob. That's pretty cool.
That's sweet.
So cool.
Cool stuff.
So we'll talk more about some of this stuff if there's interest. Hey, the Discord's really working out for making suggestions for what to talk about. So I posted the Discord link at the top of the chat window for the YouTube here. Come join us, and we'll talk. We talk during the week. So some weeks are more chatty than others, But we
Had
have a
some
lot
really
of fun.
cool stuff. Yeah, had some really cool posts this week. Some projects people are working on that are fascinating. It's a good place also for people to throw questions out there. If you're just trying to do something for the first time and you need a little assistance or questions answered, people in our viewership were all extremely helpful and knowledgeable. So it's a lot of fun. So jump in there and join us. It'd be awesome.
Excellent. Well, I want to thank everybody for joining today. This is something I've waited a long time to do. I was prepared to be underwhelmed, and I'm actually seeing more there than I thought we might. You know, it's possible we would have seen ringing, but as I looked more and more at this with the time domain reflectometer and stuff, I'm going, boy, there's no major sin here. This is about the signal itself in crosstalk, or you know, a propensity. It was a late signal to begin with and just crosses the line.
Yeah. Yep.
So
cool.
All right, excellent. Hey, so we'll see you again, Ben, my friend, next week.
Yep. Hopefully I'll have more of my lab situated, and
yeah, we look forward to seeing that.
Change up my background here, and it'll be more organized. But hey, it's good to see you, Bill. Always good as
all right.
As always. So, and thanks everyone for joining us today. We had a good show up today, 40 or 50.
Yeah,
people.
we had twice the number of viewers.
So
yeah, excellent.
Keep spreading the word. We want to grow this, and we just do it because we love it, and we know there are people out there like yourselves who love this stuff, and we occasionally want to get some of you to join as possible to show off things as well and have guests. So it's all good.
Well, I want to get Alan back on. By the way, Alan Wilkie just did a thing I saw over at Tektronix about scope probes, and I wouldn't mind having him see if he'll give us the same class. And I always, even though we think we know how scope probes work, I always find something I didn't know whenever he talks.
Yep.
So,
yep.
Excellent.